Hello. Look, in a previous video, I made an error. I was just viewing, and I want to go through a couple of points that I made in an error that I made. So let's have a look at what we were talking about on this screen. On this screen, we see that I was talking about this function. I'm just going to highlight this. No, I won't use screen. Okay, here we have the function of the normal distribution. And I said if I have a 10 in this position here, okay, let's go up to, let's change some color. Let's get a color that I can use. Let's make it red because it was an error. I'll make it orange. All right, it's already red. Okay. We were transforming the original equation. The screen just went off, so I'll try to come back on again. As soon as it comes on, I'll have to share it again because I think it's dropped out. Let me just share that screen again. Now, when we transform the original normal distribution, and if I wanted to, let me just wait till it presents. Yeah, I wanted to take the original scale from 1, 2, 3 to stretch it out by a factor of 10. And I mentioned I need to divide the x by 10. However, when I put it in, I didn't divide the x by 10. I put it under the denominator. So I'd like to just take that, rub that out from there, the 2 back. We needed to put the 10 inside with the x. Now there's still a square there. So by putting the 10 in here, doesn't put it underneath with the 2. In fact, that would become 10 squared. That would become 100 under there, not just a 10. So it's got a 2. And so the standard deviation, I'll just put, that becomes the standard deviation. If our standard deviation is 10, we divide by the standard deviation. And really, that bracket, if it's x, then it's just x. But what we're doing here is we're taking our z value and we're transforming our z value across 50. So when we transform across the mean, it'll be minus the mean. And if we have a scale factor of 10, then that's like dividing by 10, and that goes in that bracket. So in that position, we put the mean here. So if it transforms across by 30, the mean of this one is 30. And if the standard deviation was 5, we have to put not a 10 under there. That's still going to be a 2. But I want to put the 5 in here underneath this bracket, in with that bracket there. That becomes divide by 25. I could have put a 50 here. And so be careful. I just wanted to highlight that error from the previous example. So I'll just run through one more example up here. And the other example was, if this is the function, 1 over, say, 3 root 2 pi, and e to the power of negative x minus, say, 18 over 3 squared over 2. That's the original 2, right? It's still over 2. That's part of the original formula. And this formula here means that the mean is 18. So there you see minus 18. We transformed it across to 18. So we've got our middle line has moved from 0 to the right across by 18, and the screen's dropped out. Does that mean I've stopped sharing? Let me just hope that it comes back on again so I can wrap this up. Sorry for the delay. Just waiting on the computer. My computer's going on the blink, and now I'm just going to sit and hope that the screen comes back on again if I do nothing. So if the screen doesn't come on, I would hope that that x position in the original equation, it says x squared. What you need to do is put a bracket around the x. And if we're going to transform the original normal distribution across to, so the middle line is the mean line. If the mean is 50, it's going to go x minus 50. If the mean is 18, it's going to say x minus 18. But then if we stretch out our factor from being a standard deviation of 1 every 1, but we now want the standard deviation to be, say, 3, then you have to take the x minus 18 and divide it by 3. Don't forget to divide the initial power, the initial factor 1 over square root of 2 pi, 3 in there as well. Well, I think I'm going to finish now. The screen did come on. I just want to let's see if we can wrap this up by try to present one more time and finish it with the computer on the whiteboard if we can. And let's hope this works. All right, so there's across 18, and every 3, 21, 24, 27, down 3, down 3, down 3, and that will be the formula if we transform our original equation. So be careful with that. I just wanted to highlight that. It's something that I made an error while I was running through it before. It's the old grey matter, getting old, but we've got to put the standard deviation in with that bracket. We can't just put it underneath with that 2 like I did before. So hopefully we've addressed that error. I will refer to that in the previous video as a comment. Good luck.